Hello, this is section 1.6, the natural logarithm for Calc survey. So this is actually a really important section, even though it's complete review, but it's something that you need to be very comfortable with. This is, when I first started teaching calculus, this was the one thing that I'm like, oh wow, you're just expected to know how to do this and know that it needs to be readily available, when this is a concept that is still fairly new to you. You just learned this in Algebra 2 and did a little bit in pre-calc, but it's just not something that you've been doing since middle school. So natural log is the power of e needed to get x. And the whole idea is, in this class, we're going to be using natural log, but natural log is, of course, log base e, and that's what I've written up here. So, and this is a topic that if you still feel like I just have never grasped logs, then you need to come see me. Get in during SRT and I will happily sit down with you and try to make sure you understand maybe the concept behind them. Or I can show you some videos that do a good job of explaining. For our purposes in this class, you need to make sure you understand how to use them to solve. That's the big goal here. Now, properties of logs, these are just the really basic properties. So if you have natural log of a times b, you can break that up. Natural log of a plus natural log of b. Natural log of a over b, you can break that up. And remember the denominator, that needs to be the minus natural log of b. And remember in the last video, I talked about common mistakes. So just be careful. If you have natural log of a raised to p, as long as it's a that's being raised to p, you can pull that p down in front. Then natural log of e to the x, that natural log and e cancel and you're just left with x. And then e raised to the natural log of x equals x. And this is a really important last two properties that we're going to use to help us solve. Okay. So that's what I've done over here. So if you had started with natural log of x equals c, natural log of x equals c. If I want to try to get x by itself, I'm going to use this number 5 property. I'm going to base e both sides, which is perfectly legal. Perfectly legal. But what this does is this property says, hey, that e to the natural log of x, that e and natural log can cancel, so you're just left with x equals e to the c. And now I was able to start with this natural log of x equals c, and I now was able to solve for x. All right, so I am not a fan of teachers who teach you to memorize, like this is the base, and that's the exponent, and that's your answer. I don't even know if that, I don't like that. As long as you understand these properties, you don't have to memorize anything. Now, natural log of x is not defined if x is a negative number or 0. And guys, think of what the graph looks like for natural log of x. Okay? Alrighty, so example 1, solve for t if 4 to the t equals 9. Okay, now, I always tell students there's two types of problems. There's problems where you need natural log or logs to solve, and there's problems where you're trying to get rid of them. And in this case, to pull that exponent down, I need natural logs to solve. So that's the first thing I'm going to do. I'm going to natural log both sides. And now now I can pull that t down in front. So I'll have t times natural log of 4 equals natural log of 9. Then just simply divide both sides by natural log of 4 and you are done. That's it. It's the exact answer. Do not rewrite this as natural log of 9 over 4. That's a completely different answer. Don't make that mistake. Now, for this next problem, you have to be careful. Notice that when we did natural log of e to the x, it needs to be e to the x. You can't have another number in front of it like this 3 here. Get rid of that 3. So that's the first thing I did. Divide both sides by 3. That's how I got this. Then I natural logged both sides. So natural log of 5 equals, and then I was able to pull down that 2t, and of course natural log of e is just 1. Divide by 2, and there's my answer. And this is your exact answer. I will often, and so will IU, ask for exact answers. Because I know you guys could graph both sides, find the intersection point, and give me this decimal answer. But that's not what I'm going to want. I'm going to want the exact answer. Okay? So, exponential functions. So here we go. Here's where we're actually going to need these skills. So, just a reminder, when a is greater than 1, we know that it's an exponential growth. When a is between 0 and 1, it's a decay. If k, so notice we're reintroducing PERT over here, PE to the RT or KT. The only reason they do k is they're distinguishing between the rate with this annual growth rate over here. Okay, so in this function, this continuous growth rate function, when k is greater than 0, it's an exponential growth. K is less than 0, it's an exponential decay. K is called the continuous growth or decay rate. So oftentimes it does not matter which equation you use. The only time it will matter is if they specify what the rate is. And I'll show you that here in a minute. All right, so you need to be very comfortable with these types of problems. So convert the function p equals 1500 e to the 0.3t to the form this, p equals p initial a to the t. So just, guys, start with what's different. Notice they both have p initial in the same spot, so that's going to remain the same. Notice 1500 over here, nothing different. It's this last part. And they both have t in the exponent spot, so that's going to stay the same as well. So really, we're just taking the e to the 0.3 and setting that equal to a. Then if you just put that in your calculator, there's your a value, and you're done. So converting it from continuous growth rate to your annual is pretty straightforward. Now the other way is a little bit more challenging. So convert the function, we're starting from our annual growth rate to our continuous growth rate. So again, what's different? Focus on that. The 300's the same, t is the same, so that's over here. I need to take that 1.25 and set it equal to e to the k. So 1.25 equals e to the k. So then you can see that I natural logged both sides. Got to get that k out of the exponent world. So natural log of 1.5 equals, and then natural log of e is 1. So I just have k left over. Put that in your calculator. Usually I round k out to at least 4 or 5 decimal places if they don't specify. There it is. And guys, if you take these two formulas and you plug a time in, you'll get the exact same answer out. And you'll notice the rates are not that different. 0.3 was your continuous growth rate. Our annual growth rate is 0.34986. That's pretty close. Same thing over here. They shouldn't be drastically different. 0.25, 0.223. But these two formulas, if I plug in a time, I'll get the same answer. I'm going to move my little face up here. Okay, and then the last example. So during a recession, a firm's revenue declines continuously so that the revenue R measures in millions of dollars t years since time is given by this formula here. Right, calculate the current revenue and revenue in 2 years' time. So current would be plugging 0 in, and that's what's here. You get 5 million. And then 2 years' time, plug 2 in and you get 3.7 million. Use your calculators, obviously. After how many years will the revenue decline to 2.7 million? So this is when you're going to set the function equal to 2.7 million. And here's where you'll need your algebra skills. So get that e by itself. Divide both sides by 5, which is what I have here. Then natural log both sides, so we can pull this down. So natural log of 0.54 equals negative 0.15t. And then just simply divide by that negative 0.15. And you get 4.108 years. Now, be careful. That's going to be in the 5th year because you went a little past 4. Okay. So email me if you have any questions. Make sure you are practicing. We'll have more practice in class. I'm going to offer lots of practice with these exponential functions. Always on the IU exams, there's going to be at least one problem where you're going to have to be able to solve using natural logs. So we need to make sure you're very comfortable with these and you're going to use them all throughout the year. So please make sure you're doing your homework, and in class, we'll give out some extra practice or post that extra practice on Canvas. Okay, thanks.